Okay, looking at it, consider the system of linear equations. It's four equations, four unknowns. Immediately looking at it, we do have a solution to the problem just by looking at it, where W would equals X, would equals Y, would equals Z, would equal 0. So it's definitely a solution to the problem. So you could throw this one out over here. All right, that it's consistent. There is a solution to the problem, at least one solution to the problem. Looking at it, though, I want to point out that I would probably try to put it into reduced row echelon form, or at least try to get to that. All right, I know that's difficult, but you're going to write a matrix down, an augmented matrix down, and that would be, just looking at the W's, 1, 1, 3, 2. Let's see, 3, 4, 5, 5. I'm doing the W's and just did the X's. Let's see, 3, 4, 5, 5. And let's do the Y's. So that's going to be, let's see, 2, 1. Let's see, 10 and 5. And then the Z's, there's going to be 2. The second equation has no Z's. And then 14, and then 6, and the constants are all 0. All right? Now, getting it to reduced row echelon form, it does take some effort. Well, some simple things you could do is just, like the first two rows, you could take, row 2 and subtract row 1. And then you could do 3 times row, minus 3 times row 1 plus row 3, minus 2 times row 1 plus, so forth and so on. But you'll get to this form over here. It goes pretty quickly, but you get to this form over here. And looking at that, I want to point out, kind of looking at it, I see that, 0, zeros, rows, and at the bottom, certainly. So I want to write this one down for you. And that would be, let's see, that would be read as X equals, let's see, Y plus 2Z. And the first row is a W would equal minus 5, let's see, XY, and then minus 8Z. So then, the problem is I got to get the Y and the Z. All right, now tradition has it, we would just simply assign the Z to be some real number A. That could be any real number. And then next up from that would be B. That could be any real number. So now I got some ordered pairs over here. And let's write this down for you. Starting with the Z would be A, and then you get a B. And then for X, you get what? You would get Y, which is B plus 2A. And then what do you get for the W? You would get, let's see, the Y is B, so minus 5B, and then minus 8A. All right, let me show you that's written. That's written right over here. All right, kind of looking at it, I know I can throw this one out now because there's an infinite number of solutions, so this is going to get thrown out now. Let me get my eraser out. This is thrown out. This is thrown out. All right? Now, certainly C, D, and E, I got to consider now. So looking at D, I'm going to say, is that possible? Well, let me just write it down for you. If this is 1, right? Nope, they said it's 0, didn't they? 0. This would be 1. This would be 1. And this would be what? That would be minus 5. So this one could be thrown out. All right? We're looking for false statements, by the way. Okay, I got C and E to consider. And just looking at those two, they're going to require a little bit of thinking. All right, let me erase this business over here. I'm having suspicions that E is not going to work out so well. And the reason I'm saying that, they say that every solution is a scalar multiple of that. Well, let's write another one down that's not a scalar multiple of that. And I'm going to put this down over here and use simple numbers, by the way. 1, 1. And what would you get over there? You'd get 3. Again, we're using this over here to do this. And then you get minus 5 minus 8 is minus 13. And that's definitely not a scalar multiple of this. Not a scalar multiple. So I'm going to say this one over here, right? Now, if you want, I guess you could go to verify this one over here, but you could verify this by picking, some arbitrary constants, instead of A and B to use C and D, and you could show that that's okay. All right. Again, so I'm going to choose A. E is the correct choice. Thank you.